Hello students, so today I'm going to be going over the chapter 4 review, which should have been your homework, and the pages were 92 through 93. I don't remember if I assigned only odds or not. I feel like I did, but I'm going to go through some of them. Maybe I'll go through some of the evens so that then you know how to do the odds. But I'll go through more than that. You should have done this work before you came to this video, so make sure that you have done something on your own or tried it on your own before you come over here to work on it. Okay, number 1, 2, and 3 say to draw a model. So number 1 says a number line to represent 5/6. So when you're drawing a number line, you draw your number line, and then if you start at 0 and you're going to 1. If you're trying to go by sixth, then you need 6 spaces, not 6 lines, but 6 spaces. So if I have 6 spaces, that means I'm going to have 5 lines. And sorry about the dog in the background. He's being a little bit of a pain. Okay, so when I grade yours, I will be checking to make sure that you have the right amount of lines. So this is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. And remember, 1 is the same as 6, 6. Okay, so it wants me to graph 5/6. So to graph it, you put a dot where the 5/6 would be. You don't have to label all of them, but you do need to put a dot in the right location. Okay, number 2 says a set to represent 3/8. So a set means I'm going to have like multiple shapes or items. So if I'm doing 3/8, the bottom number, 8s, is your total number of sets. And then when I put 3, I'm going to shade 3 of them. So this is how you represent 3/8. I don't know if y'all did number 2, but it's just more practice. Lumpy, stop. Sorry, my dog is tearing up something in my room. Okay, my puppy. Number 3, a figure to represent 4/7. Right? Okay, so a figure means just one shape. So I'm going to do a rectangle, and then it says 7, so that means I need 7 spaces, which means 6 lines. So this is going to be, let me see if I can figure out, 1, 2, 3, 4, 5, 6. So did that give me 7? 1, 2, 3, 4, 5, 6, 7. Yes. So now I'm going to shade in 4 of them. So the bottom number is always the total, and then the top number is what you're shading, so 4/7. Okay, hopefully most of y'all got those. Okay, number 4 through 6 say draw a model, write the improper fraction as a mixed number. So for number 4, it said to draw a model, and the number is 5/2. Okay, so we want to draw a model of 5/2. Okay, well, a half, we'll stick with some triangles. Okay, here's a half. Well, that's 2/2. Okay, I'm trying to get to 5/2. That's 2 more, so that's 4/2. I want 5/2. Okay, so this is 6/2, but we want to only shade 5 of them. So 1, 2, 3, 4, 5. So each of these is split into halves, and then I shade it 5 sections. Now let's look at what's shaded. We have 2 whole triangles shaded, right? So that's those 2. And then we have half of one over here. So 5.5 is equal to 2.5. And we show that from our model. Okay, number 5 says a circle to represent 7/4. So this time it told me circles, and it wants it split up into fourths, and they want 7 of them. Well, this is 4 of them, so I need 3 more. So there's 3 more, well, 4 more, but we're only going to shade in 3 of those. So I want to shade in 7/4. So that's 4/4, 5/4, 6/4, 7/4. Now it wants you to take these 7/4 and change it into a mixed number. So I have 1 whole circle shaded here. So that's 1 whole. And then over here, I have 3 out of 4. So that's 3/4. So this picture is showing 1 3/4. So 7/4 is equal to 1 3/4. And we show that through a picture. Okay, number 6, rectangles to represent 9/5. Okay, so it says rectangles. So, and I want them split up into fifths. So 1, 2, 3, 4, 5. And so I need 9 of them. So I need another one. 1, 2, 3, 4, 5. Okay, and now I need to shade 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so this was 9/5, but I'm going to switch it over into a mixed number. So I have one whole rectangle shaded. So that's one whole. And then over here I have 4 out of 5 shaded. So 1 4/5 is the same as 9/5. Okay, moving on. The next one is where we found the blank. We're trying to make equal fractions, and one side is blank, or one section is blank. And y'all were pretty good at this, so hopefully we don't have too many that are struggling with this. But this is number 7. So you look at the one that has both numbers, so 8 and 24, and you say 8 times what is 24? Well, 8 times 3. So then you do the top the same way, 3 times 3, and what does that equal? So that's going to equal 9, so that means n equals 9. Okay, let's do another one. We're going to do 4 of these, so give you some extra steps in case you are struggling with this. 4/7 equals 16 over n. So look at the one that has both numbers, so 4 and 16, and say 4 times what equals 16? Well, 4 times 4 equals 16. So then you have to do 7 times 4 on the bottom. So that's 28. So that means 7 times 4 is 28. So that means n equals 28. Okay. Number 9. N over 12 equals 25 over 60. I think that's what that says. Okay, so this one's a little bit backwards from what you're used to, and you could do it 2 different ways. I'm going to show you this way. If I look at the ones with both numbers, just like before, and I'm going to go backwards, so I'm going to go 12 times 5 equals 60. But up here we have n. So we have n times 5 equals 25. So that means you have to say what times 5 equals 25. So the answer is 5, right? 5 times 5 equals 25. Okay, there's another way to do this too. You can work backwards and you can say 60 divided by 5 is 12. 60 divided by 5 is 12. So 25 divided by 5 is what? Which is 5. So same answer. Okay, number 10. Number 10 is 5 over n, so it's the same type of problem, equals 15 over 18. So you could do it both ways like I showed you before. You look up at this top and it says 5 times 3 equals 15. So you could say n times 3 equals 18. What does n equal? So what times 3 equals 18? Y'all have multiplication charts you can use. The answer is n equals 6. You could also say 15 divided by 3 is 5, so 18 divided by 3 is 6. Either way works. Okay, now we're on to number 11 through 16, and these say rename any improper fractions as a mixed number, or if it's a mixed number, change it into an improper fraction. So let's start with number 11. Is number 11, which is 17 over 10, is that an improper fraction or a mixed number? It's an improper fraction. If the top is bigger than the bottom, then it's called improper. And now we're going to change it into a mixed number. So this is what you say to yourself. How many times can 10 go into 17? It's 1 time, so that's a big number. There's 1 10 in the number 17. Then you say how many are left over after you take out that 10? Well, 7 are left over and 10 goes on the bottom. Now, some of y'all need to do the division way. So this is how you do the division way. Top number always goes inside, bottom number on the outside. 10 goes into 17 1 time. That's your big number. Then I subtract. 7 is how many are left over. And the 10 on the bottom just stays the same. Okay, and that's it. Okay, number 12. Number 12 is 5 halves. So another improper fraction. Say 2 goes into 5 how many times? How many 2's are in the number 5? There are 2 2's, right? Now, once you've taken out those 2 2's, which is 4, right? How many are left over? 1 and 2 stays on the bottom. Okay, you can also do it the division way. So 2 goes into 5 2 times, that's 4, and I have 1 left over. So there's the 2, there's the 1, and the bottom number 2 is this number. Okay, number 13. Number 13 is 23 over 5. So you say, how many times does 5 go into 23? 4 times. Okay, if you're using your multiplication chart for this, then look for any numbers that are, on the 5 column or row, you look for the closest number to 23 that's under 23. Okay, it's going to be 20. Then you look across and say, okay, that's 4. So 5 goes into 23 4 times. I have 3 left over, and 5 stays on the bottom. That's it for number 13. Okay, now we're going to go into mixed numbers, changing them into improper. So most of y'all said this section was easy, so hopefully you got these right when you did these on your own. So number 14 was 4 2/3. And remember, when we change mixed to improper, we go 3 times 4 is 12. And then you add the 2 on top. So that's 14 over 3. Leave the bottom the same number that it was. So that's 14 over 3. Okay? Okay, 15 and 16. So 15 is 3, 3 2/8. Number 15 is 3 2/8. So I'm going to do 8 times 3 is 24 plus the 2 on top. So that's 26 over 8. And that's it. That's all you have to do. Times and then plus. Keep the bottom the same. Okay, number 16. 1 7/12. So times, 12 times 1 is 12. Plus 7 is 19. Keep the bottom the same. Pretty easy. Times and plus. Times and plus. Up here, when you're doing this one, it's kind of the opposite. Divide and then minus. So divide and then minus. So times and plus, divide and minus. They're just the opposites of each other. Okay, 17 through 19 is asking you to find the GCF of different numbers. And they actually give you, so we have been doing factor trees for this. Well, in this one, they actually give you what the factor trees are, would give to the problem. So on number 17, it says 28 is 2 times 2 times 7, and 35 is 5 times 7. So you're looking for GCF. So for GCF, all you're looking for is what they have in common. So 7 is what they have in common, so your GCF equals 7. That's it. If you have a problem where you do this, the factor trees. Now, we didn't always do factor trees. You could also do it with its, I'm going to show you the other way to do it. You could also do it with its factors. So for 28, the factors are 1, 2, 4, 7, 14, and 28. Now you have to make sure you get all the factors or you're going to get it wrong. For 35, it's 1, 5, 7, and 35. So the only factor they have in common is 7. But if you forgot the 4 times 7 up here, the 5 times 7 down here, then you're going to get it wrong. This other way, you don't get it wrong. You have all your factors there. Okay, number 18. Again, it's going to be the same one, same kind. They take two numbers and they write out the factors for you. 2 times 3 times 3. And 27 is 3 times 3 times 3. You circle the ones they have in common. Now this time, this one has 2 of them in common. So you take each one, 3 times 3. You just write it 1 time per circle. And that equals 9. So my GCF is 9. Now if I had done it this other way, which some of y'all are still trying to do, and that's okay, but you have to know your multiplication really well to be able to do this one. Make sure you get all your factors. Okay, so there's all my factors doing it that way, where you write down all the ones that multiply together. And on this one, I get 9 as my GCF, which is the same I got on the other way. So you can use either way. It's the same answer. Okay, number 19, we have 12 and 20. So for 12, we get 2 times 2 times 3. And for 20, we get 2 times 2 times 5. So circle the ones they have in common. And then those are your GCF, 2 times 2. You only write them one time for each circle. So 4 is my GCF. Okay, now we're going to go and do the same thing that we did here, but we're going to do LCM, which is a little bit different. So on number 20, they have this 28 and 35. That was the same one we did up here, right? Okay, but this time we're doing LCM. So for 28, and this time they wrote it a little bit differently. They wrote it with exponents. So they put 2 squared times 7. And for 35, they put 5 times 7. Okay, well, I don't want you to try to work it like this. So I want you to rewrite this as all the things. And I'm going to redo this one down here. Oh, sorry, I put those dots. That's what we do in algebra. Okay, now you're going to circle the one you have in common. Okay, and like GCF, we'd write that one down only one time when it's circled. But we're trying to find LCM, which is least common multiple. Multiple means I'm going to have big numbers, right? It's going to multiply. So I need to write down this 7 one time. That's their GCF. And then I'm going to write down all these other numbers just one time. So 7 times 2 times 2 times 5. So each of these got written down and once, and then this got written down once, not twice. So now I can work this out. That's 14 times 10. That's 140. Okay, so my LCM for 28 and 35 is 140. Now you could also list out their multiples, but I'm not going to do that because I don't want to list out multiples for 28 and 35. It might be easy enough to do for when you're doing 2s and 8s and all that, but when you get into these bigger numbers, it takes a lot longer to list out the multiples. Okay, maybe I'll do it on the last one for y'all. Okay, 28 is 18 and 27. So they're going through the same ones that we did GCF for, and they're putting exponents. So on this one, it said 3 squared, but I'm going to put 3 times 3. And the bottom one says 3 times 3 to the 3rd power. So I'm going to put 3 times 3 times 3. Okay, circle the ones they have in common and write out each of those only once. Okay, and now with these two that are left, the 2 and the 3, I'm going to write those out also. Times 2 times 3. So the ones that are circled that they have in common only get written one time because they have that in common. Okay, now I'm going to multiply this. So 3 times 3 is 9. 2 times 3 is 6, so 9 times 6 is 54. So the LCM of 18 and 27 is 54. Up here, we did the GCF of 18 and 27, which was 9. So that's a lot smaller. GCF is smaller, LCM is bigger. Okay, because LCM is about the multiples, and multiples means bigger, like you're multiplying. Okay, 22 is 12 and 20. And for 12, that's 2 times 2 times 3. And for 20, that's 2 times 2 times 5. So I'm going to circle the ones they have in common. That's 2 times 2. Just write them each once. And then I'm going to write these extra ones off to the side. Okay, so now I'm multiplying all of this. So I have 4 times 15. So that's 60. Now, the other way, I told you I would do this last one the other way. If you're doing multiples the other way, then you list out their multiples. You like skip counting. 12, 24, 36, 48, 60. Okay, and then for 20, it's 20, 40, 60, 80. Well, I could have stopped at 60 because there's my least common multiple is 60. So you could do it with skip counting too, but some of them like this one right here, 18 and 27, that one is not as easy to skip count. So you might think about doing it this other way, which we use factor trees for. Okay, now 23 through 25 are factor trees. Remember, we have talked a lot about how factor trees can look different for each person. So yours may look totally different than mine, but the final answer should look the same. So 24 is 4 times 6. It could be 2 times 12. It could be 3 times 8, but I'm doing 4 times 6. So 4 is 2 times 2. And once you get your prime numbers mean you can only have 1 times 2 or 1 times 3. They only have 1 times themselves. But composite numbers, you can do more than the 1 times. So 6 is 2 times 3. 2 and 3 are prime numbers. 4 is not, because 4 can be multiplied by 2 times 2. Okay, so there's my ending. I have everything circled. There's no more branches. So 24 is 2 to the third power times 3. And those are all my answers. Now, some of y'all are still writing it out like this, and that's okay, but I'd like to see exponents written. Okay, number 24. Number 24, the factor tree is for 36. So I'm going to do 6 times 6. You could do other ones. And then that gives me 2 times 3 and 2 times 3. And both of those are prime. All of those are prime. Okay. Some kids were doing 6 and they were doing 3 times 3. Or they were putting 3 and 3 because they were like 3 and 3 makes 6. But this is multiplication. So make sure that it's 2 times 3. Okay, so now I'm going to write these as factors. I have 2 2s. That means 2 squared, or 2 to the second power. And I have 2 3s, so times 3 to the second power. And there's my answer. Okay? Okay, 25, last factor tree, is 40. So for 40, you can do 4 times 10. I'm going to do 5 times 8. Okay? Oh, but 5 is a prime, so it can't have a branch off of it, because the only thing, if I did this, then I would get 1 and 5. And remember, in factor trees, we can't use 1s. Okay, so 5 is prime, so I'm going to circle that. 8 is 4 times 2. 2 is prime. 4 is 2 times 2, and both of those are prime. So look at what you have circled. I have 3 2s, 2 to the third power, and I have a 5 over here. Okay, 2 cubed times 5, or 2 to the third power times 5. Okay, we are getting close to done, but not done yet. Let's see, we have 26 through 31 are to write a fraction in lowest terms. Write the fraction in lowest terms. Okay, so we did a little bit of this. The first one is 8/12. Y'all hear my puppies barking? It's the morning and they're very excited and it's raining outside. Okay, so 8/12. What can both of these numbers be divided by? Well, they could both be divided by 2. We know that because they're even numbers. But think if you know a bigger number that they can be divided by. So this is like finding the GCF. Okay, so you're dividing by the GCF. Well, both of these can be divided by 2, but they can also both be divided by 4. So you just have to go through your factors for each one and see what the biggest one is. So 8 divided by 4 is 2, and 12 divided by 4 is 3. When you finish, look at it again and say, can I simplify it anymore? Can I reduce it anymore? Can 2 and 3 be divided by anything? No, it cannot. And when they are only one number apart, like 2 and 3 are only one number apart, for sure they cannot be simplified anymore. Okay, 27 was 12 over 30. So 12 over 30. I can divide both of these by 3. Okay, so that's 4 over 10. I look at my problem and I say, wait a minute, 4/10. Those can both be divided by 2. When that happens, that just means you didn't pick the GCF here. I should have divided by 6, and then I would have only had to do it one time. But that's okay if you don't do it, if you only do it by 3 that time and then by 2 the next time. that's okay. I still get 2/5. See, I could have, easier way would have been to divide by 6, but 6 wasn't the first thing that popped into my mind. But when I divide by 6, I still get 2/5. So either way, I get the same answer. Okay, number 28. Let's see, this number is, I can barely read this. Okay, 28 over 35. So both of these can be divided by 7. So 28 divided by 7 is 4, and 35 divided by 7 is 5. If you don't know what they can both be divided by, look on your multiplication chart and try to find one of the rows that have both these numbers in it, and that should give you what they're divisible by. Okay, 29 is 32 over 64. Okay, so I know that both of these can be divided by 32, but some of y'all might not know that. So you might start by dividing by 2 because they're both even. So that's an easy one to say, oh, these can both be divided by 2. And then you would get 16 over 32. And what if you still said, oh, I think they can be divided by 2? Or maybe you look at this and you say, oh, these can both be divided by 8. Or you look at your multiplication chart and see that they can both be divided by 8. So now I get 2/4. Well, I can still divide. They're still divisible by 2. So when I divide by 2 here, then I get 1/2. And that's my final answer. So look at all this division I did. I could have started here by dividing by 32 and gotten the right answer right away. But I did not think that y'all would think that in your head. So I want to show you what you might be doing. And this is okay as long as you get to that final answer of 1/2. Okay, some of y'all might have done it even different than that. Okay, number 30 is 14 over 50. Okay, if you have no idea what to do and the answer to what you can divide by isn't on your multiplication chart, always think of your divisibility rules. These are both even, so I can divide these both by 2. Okay, so that's 7 over 25. And then say, okay, is there anything else that I can divide these by? And no, there's not. 7 over 25 is your final answer. Okay? Okay, number 31. Number 31 is 18 over 27. Okay, so right away I say, oh, these are 9s, right? If I'm thinking about what numbers these can both be divided by, they can both be divided by 9. They are not even, so 2 wouldn't have worked. They could be divided by 3 or 9. So 9 is the highest one. So 18 divided by 9 is 2. And 27 divided by 9 is 3. And there's my answer, 2/3. Okay, the next section is on greater than or less than or equals to. Okay, I think this was the last part I had y'all do. I think we only went to 37. But I don't remember exactly. 13 over 24. I could go look at my phone, which isn't next to me. Okay, 13 over 24 and 12 over 46. Is that what that says? 46. Yes, right? Okay. So these are both numbers where most of y'all are going to want to cross multiply these, but I actually see an easier way really quickly on these, and that was the half method that I taught you. So half of 24 is 12, right? Well, 13 is more than that. So this is more than a half. But over here, half of 46 is 23. And so this is less, hush, Pepper, hush. So 12 is less than that. So that means this is bigger because this one is bigger than a half. This one is less than a half. So the 13/24 is the bigger one. So that was one strategy I taught y'all. Okay, 33 is 3 2/8. 3 2/8. And the other side is 3 5/8. It is really hard to read this teacher book that they gave us. Pepper, you're interrupting my math lesson. Hush. Okay, so the book in here has very tiny writing type. Okay, so this one's easy. Both the whole numbers are the same. Both denominators are the same. So all I have to do is look at the top numbers. So the numerators. So 3 and 2/8 is less than 3 and 5/8. Okay, number 34 is 4/5 and 4/7. 4/5 and 4/7. So they have the same top numbers, but the bottom numbers are different. So think about it like you're slicing pizza. We talked about this in class. If you slice a pizza into 5 slices, those are going to be bigger. Dog, go away. Those are going to be bigger than if I slice them into 7 pieces. So this one's going to be bigger because 4 of the pizza sliced into 5 slices is bigger than 4 pieces of a pizza sliced into 7 slices. Okay, if you don't get that, if that's kind of confusing to you, this is an easy one to do cross multiplication. So 5 times 4 is 20, and 7 times 4 is 28. So the 28 is bigger. Always start from the bottom up when you do that type. Okay, 35 is 2 6/10. 2 6/10. And 13/5. Is that what that says? Yep, 13/5. Okay, so this is one I don't think we talked about this one too much. You want to make them either both improper or both mixed. So I'm going to change this one to a mixed number. 5 goes into 13 2 times, and that leaves 3/5. So now I have 2 6/10 and 2 3/5. Well, the big numbers are the same. So now I'm just really looking at the fractions of these, right? Just the fraction part, not the mixed number. And I could do a cross multiplication if I wanted to. That was 30, and this one's 30. So these are equal. Okay. Okay, 36. We're almost done. Well, actually, I was going to make sure that what I assigned to y'all. Yep, 1 through 37. It was odd, so I'm doing all of them. So if you did all of them, then you would have answers to all of them. Okay, 36 is 5, 6, and 13, 14. So this one doesn't have a good strategy to do either way, so I'm just going to do cross multiplication. So 6 times 13, I need to go over here, and I need to work that out. 18, 78. And then this is 14 times 5, which is 70. So the 78 is bigger. So 5 6 is less than 13 14. And then my last one, and then I'll be done, and I could go let my dogs out. 3 7 and 2 5. And that's another good one to just do cross multiplication with, because y'all can just almost do those in your head. 7 times 2 is 14. 3 times 5 is 15. So 3 7 is bigger. 3 7 is greater than 2 5. Okay, so that's it for this whole review. I did odds and evens so that you have plenty of practice, and you have a test on Tuesday. And so hopefully this helped y'all. Have a good weekend.